Hello everyone, hope you all are fine. So today I am going to solve this Leetcode POTD, which is maximum length of pair chain. So first let's understand the question. You are given an array 10 pairs where pairs of I, which is left of I and right of I, and here is given that left of I is less than right of I. Okay, and a pair P2 is CD, where C is the left of I and D is the right of I, follows a pair P1. P1 is A comma B, where A is left of I, B is right of I. Okay, if B less than C. Now, here is given that a pair P2 follows a pair P1 if B less than C. Okay, so what we can say that what we can say we can say that so we have P1 A comma B. So in P1 A is left and B is right, and from the given condition we can conclude that left of I is less than right of I. So we can conclude from here that A less than B. Okay, so we can conclude A less than B. Now a pair P2, which is C comma D. So from there we can conclude C less than D. Okay. Now a chain of pairs can be formed in this fashion. Returns the length of longest chain which can be formed. You don't need to use up all the given intervals. You can select pairs in any order. Okay. I will explain this later. First, understand this portion. A pair P2 follows a pair P1 if B less than C. That means P2, that means P1 of right. Which is P1 of right? It is B. So B should be less than C. And what is C? C is left eye of P2. So from there we can conclude this condition that if A less than B, it is P1, and if C less than D, it is P2, and if B less than C, we can say that P1, we can say that P2 follows a pair P1. So from there we can conclude that P2 follows P1. Okay. Now from there we can conclude this portion. Okay. Now jump into this line which says that jump into this line. Okay. Sorry. Okay, now jump into this line. Okay, you don't need to use up all the given intervals. That means if 1 comma 2, after 1 comma 2 is given 2 comma 3, then 3 comma 4 given. It is not mandatory that first you have to take 1 comma 2, then you have to take 2 comma 3, then you have to take 3 comma 4. No, you don't need this order. First you can take 2 comma 3. Then if this condition hold, if this condition hold, okay, if this condition hold, we can take 1 comma 2. Okay, then I can take 3 comma 4, or first I can take 3 comma 4, then I can check this condition. Then if the condition is true, I can take 2 comma 3, then I can take 1 comma 2, or first I can take 3 comma 4, then I can take 1 comma 2, then I can take 2 comma 3. So from there it is clear that you can take in any order. Okay, from there it is clear that you can take in any order. So I can conclude that I can take that index or leave that index. Okay. Same, I can take that index or leave that index. I can take that index or leave that index. Okay. But but here is a twist. Let's see in the second example. 1, 2, 7, 8 and 4, 5. Okay. Now let's say in this tree. First we can say that first we can say that okay, I have taken 0, 0th index. Okay. Now we can conclude that we can we have taken that current index 0. Okay. Now if we take 0th index, now we have to take index 1. Okay. And from that portion we can say if we don't take 0, don't take 0th index, don't take 0th index. Okay. Then current index will be 1 because we omit 0. That means we leave the 0th index. Then we have to explore index number 1. Okay. Now here if I take index number 1, if I take index number 1, okay, then I have to explore index number 2. Then I have to explore index number 2. Okay. If I avoid taking a, avoid taking index 1, then avoid it. Now we can take 2, we can take this index. Okay. Now if we take 2, now we have to explore index 3. But in this example we have only 3 elements and our indexes 0, 1 and 2. So how can we access this in index 3? It is not possible. Okay. So we can say this is our base case. From there we have to return. This is our base case. Okay. Same. Here we have taken this index 2 or we can omit index 2. Okay. So if we omit index 2, our current index will be 3. I will explain this previous index later. Wait. Again it is 3. So we cannot access this 3 because our index ends at index 2. So we have to return. Okay. Again if we take 2, then we have to explore 3. Then we have to explore 3. If we avoid to index 2, same we have to explore 3. Now come on this previous index. Why we have to take this previous index? Okay. So whenever you have taken this index, okay, after taking this index, suppose you want to take this index. So first you have taken this index which is 1 in this example. Then you want to access zeros, that I want to access 0. Is it possible? No, because we are going from left to right. Whenever I am going from left to right, I can take one index and I can omit one index. Okay. And Suppose you have taken index 1, then you want to take index 2, but you have to check the condition. What condition? This condition. Because we need to form that what is the largest, what is the longest chain we can create. Okay, what is the largest chain we can create? So we have to check this condition. So how we will check this condition? If your current index is there, you have to keep track of a previous index. Otherwise, how you will check that this how you will check? If you don't have a index, or if you don't have a pointer, which I named here is previous index, which you don't have this pointer, whenever your current index is there in this position, you have two choices. Either you can take it, either leave it. So whenever you choose it, you have to check that my current index follows this condition or not. From the current index, you have the idea, or you get CD. But from where you get AB? From the previous, obviously. Suppose previously you have taken, suppose, uh, suppose previously you have taken zeroth index, then you omit that index and you want to take that index. So C and D, you know that C is 3 and D is 4. But what is AB? How to keep track of AB? So you need a previous index to keep track of it. That previously I have taken zeroth index. Okay. Now I am taking tooth index. So I have to place a pointer here. Okay. That previously I have taken this index. Now I am willing to take this index so that I can get A and B to check that condition that P2 follows P1 or not. By that way, we can get the longest chain which can be formed. Now, see this. So first, when I am on current index, which is 0, on 0, on 0, you have two choices. You can take it or you can leave it, because previously you take nothing. Okay, so you have two choices open to you. So that's why I have taken previous index is equal to -1. Okay, now you can take it or you can omit it. Okay, if you have taken index 1 0, then you have taken index 0. So now you have choices on index 1 and 2. Whenever you have taken 0 and you want to take 1, what will be your previous value or previous pointer? Obviously 0, because previously you have taken 0. That's why whenever I am choosing 0, our previous index will be now my current. Our previous index is equal to current index. Got that point? If you have taken index 0, now you are willing to explore on index 1, but whenever you want to take index 1, you have to check that, okay, previously I have taken 0. Okay, previously I have taken 0. Now if 0 follows 1 or not. So if your current index on 1, which is that, and previously you have taken 0, that's why your previous index will be now 0. Okay. If you leave 0, that okay, leave 0. Now your current index will be on 1. Now you leave 0. Okay. So whenever you are on current index is 1, you have two choices. You can take it or you can leave it. So here also previous index is equal to -1, because you have two choices. Whenever you want in current index 1, previously you have nothing to check with. That's why you have two choices here. You can take it or leave it. Okay. Now same on index 1, you can take it or you can leave it. If you take it, if you take 1, now you have to explore which index? Index 2. So you have to explore index 2. And previously, so to take index 2, from which index you have to check? Obviously, previously, previous index, which is 1. So you have taken 1. That's why our previous index is 1. You have to check with 1, that 1. If you follow 2, then I can make the chain. If you don't follow 2, I am unable to make the chain. Got it? Now, if you leave 1, so leave 1, leave 1. So our previous index is 0. Then you said, okay, don't take 1. So I have to explore on index 2, and I can take 2. I can take 2 or not take 2. I have two choices on 2. I can take it or I can leave it. Okay. But to take 2, from which index? Like for take 2, by which index we have to compare, or by which index we have to prove this condition true? Obviously, we have to check with index 0, because previously we have an index which is 0. So previous index is 0. So simple funda is that if you take the current index, your current index will be the previous index, and if you leave the current index, your previous index will remain same, and your current index always increased by 1, because if you explore on that index, now suppose you have 0, you have 1, and you have 2. That these three are indexes. So you have you can take 0 or not take 0. Okay. Now you have to explore on index 1. That's why whenever your exploration is done on 0, you have to explore the next index. So in each level, our current index will be increased by 1. Got that point? Okay, same as above, same as in this tree. If I include current index is equal to 1, our current index will remain 2, and our previous index will be current index. Got it? Because I have taken 1. Now I have to explore 2. So to take that 2, by to take that 2, before 2 we have which index? 1. So we have to check it with 1s. That's why our previous index is 1. Here leave, so our previous index will remain same, which is -1, and our current index is 2. Got that point? And already I have explained that point, that whenever our index will out of bound, that means if I have only 3 elements, that means I have index as 0, 1, 2. So it is not worth it to, or it is not possible to access index 3. That's why whenever our current index is equal to, I can say that if it is a vector of vector, so I can say that whenever our current index is equal to vector dot size. Okay, I can return from there. Got that point? Now there is a catch there. What is the catch? See. Okay, now see that catch. Here the data is already sorted. You can see 1, 2, 2, 3, 3, 4. The data is already sorted. Okay. Now why I am saying sorted data is needed? Here sorted data is needed. Why sorted data is needed? Now let's understand this thing. Whenever you are on 1 comma 2, your 1 comma 2 is a b, I can say, and 2 comma 3 is c d, I can say. So I need a index b which is less than c, or I need a index c which is greater than b. How to gain this condition? It is a sorted thing, I can say. I can say it is a sorted thing, obviously. So if you sort that data, there is a maximum chance there. If you sort that data, there is a maximum chance that the length will increase. Okay, there is a maximum chance that length will increase. Let's discuss this with example 2. Suppose you have taken 1, 2. Okay, after that, is it possible to take 7, 8? Obviously, 2 less than 7. So, take it. So, now our chain length is 2. Okay, after 7, 8, is it possible to take 4, 5? Is it possible to take 4, 5? 8 less than 4. No, 8 is not less than 4. So, it is not possible to take 4, 5 after 7, 8. Okay, so by that our maximum length is 2. Okay, now we can conclude that, okay, I leave that index. So after 1 comma 2, is it possible to take 4 comma 5? Obviously it is possible. So our chain length will be 1 comma 2, then I can attach 4 comma 5. So again 2. Okay, you can also say that okay, mm, leave 1 comma 2, leave 1 comma 2, leave 1 comma 2, and take 7 comma 8. After 7 comma 8, is it possible to take 4 comma 5? No. Because why no? See, why I am saying it is no. See, here it is 8 and here it is 4. So 8 is less than 4. No, 8 is not less than 4. So chain formation is not possible. Okay. So if we take 7 comma 8, we can only form a chain with length 1. But we have better answer, longest answer 2. Okay, now you can say that, okay, mm, okay, now you can say that, now you can say, don't take 7 comma 8, start from 4 comma 5. Again, if we take 4 comma 5, we have a chain length of 1. But see the answer, it is 3. Why I am getting wrong answer? Because I have to I have to fulfill this condition. To fulfill this condition, what is my requirement? I need a requirement so that B is less than C. B is less than C. How to achieve maximum of pairs? How to achieve this? How we can align maximum of pairs? How we can align maximum of pairs so that we can get this condition B less than C? Just sort it. See 1 comma 2. If we sort that data, 1 comma 2, okay, 7 comma 8, 7 comma 8, and 4 comma 5, 4 comma 5. If we sort this, what I am getting? If we sort this, what I am getting? This portion I am getting that 1 comma 2, then 4 comma 5, okay, and then 7 comma 8, 7 comma 8. Okay, now I can start from here. Is it possible to take 4 comma 5 after 1 comma 2? Yes, because 2 is less than 4, so it is possible. After 4 comma 5, it is possible. Is it possible to take 7 comma 8? Obviously possible, because 5 less than 7. So we have a maximum chain length of 3, which is answer. So how to achieve this? How to achieve maximum of pairs? Follow this condition, that B less than C. Just sort it. Then only you can have that condition, that maximum of pairs follow this rule. Okay, got that sorting point? Why we have to sort the data? Now jump to the code. Okay, now jump to the code. First, obviously it is take non-take problem, which is 0 1 knapsack problem. So we have to use recursion. So that is the recursive code. First, we have to sort that data, as I earlier mentioned and explained that thing. So sort that data. Then I have to initialize previous index with -1, and I have to initialize current index with 0. Why I need to initialize -1 to previous index? I have mentioned that thing, that on index 0 I have two choices, because before 0 I haven't take nothing. That's why on 0 I have two choices. I can take it, I can omit it. Okay, because before 0 I haven't take anything, so I don't have to check something with 0th index. I don't have something to check with 0th index, that it is a valid point or it is a invalid point. I don't have to check this. That's why here previous index initially initialize with -1. Okay, then previous index, current index, got it? Previous index and current index. Okay, now this case, take and not take, take and not takes, two variables. Okay, now if previous index is equal to -1, if it is our first index, that means then we can take it. So if we take it, our length increased by 1, our chain length increased by 1, and we can recursively state that, okay, I have done it for one index, which is I have done it for index 0. I have done it for index 0. If for index 0, I can say if I take 0th index, our chain length will be 1 or increased by 1. Now, in future, said for index 2, index 3, index 4, return me the highest length you can form. Return me the highest length you can form. As I already mentioned in this tree diagram, as I already mentioned in the tree diagram. Okay, so I have done this. That take is equal to, if I take this, our length will increase by 1. Then explore for current index plus 1. You have taken current index, now explore for current index plus 1. And if you have taken the current index, suppose you have taken 0th index and you want to explore for one index. You now your previous index will be what? 0, which is previously the current index, which is previously the current index. So now your previous index will be the current index. Okay, and your current index will be current index plus 1 for the next level, which you can see previous index minus 1, current index minus current index 0. If you take it, your previous index will be your current index, that means previous index will be 0 and current index is current index plus 1. Got it? That point. See this tree. Now you can take it, but it is first index. That's why you have taken that. If it is first index, we don't have any previous index. That's why we can take it. But if it is not, if previous index is not minus 1, that means we have like index 1. Previously we have taken index 0. Then we are on index, current index is 1. So we have two choices. We can take it, we can omit it. On which condition we can take it? If this condition holds, that if b less than c, that then we will take index 1. So here we have to check that thing. So pairs of previous index of 1. Pairs of previous index of 1. Why? Pairs of previous index of 1. Now see, if you have taken previously this thing and you want to explore on this. So if you take this, you need that index which is previous index, it is stored. Now previous index 0 and previous index 1. Okay, so return that thing, pairs of previous index of 1. Okay, and pairs of current index of 0. Why current index of 0? Pairs of current index of 0, it is 0, it is 1. So we have to check with 0th location, because we have to check this thing with this thing. Pairs of previous index, this is 0, previous index of 1, and pairs of current index, which is 1, of 0. Got that point? Why I have written this thing, that previous index of 1 should be less than previous in current index of 0. Okay, now if we omit that, we don't have to take that index. In this case our length will be 0 basically, because we omit it or we leave it. Now we have to explore for other indexes, and if we don't take that index, suppose you have 0 and you have 1 but you omit it, now you have 2. So your previous index is 1 or 0. Obviously you have to check with index 0. So your previous index remains same, your previous index remains same, and you have to explore for the next index, that is current index plus 1. And from take and not take, whichever index or whichever variable will give you maximum length, take or non-take, whichever variable will give you maximum length, return simply this thing. So it is recursive condition. But for each index we have two conditions. So our time complexity will be 2 to the power n, but we have n equal to 100, 1000. We have n equal to 1000, so it will eventually give me a TLE. So we have to optimize it. Now how can we optimize it? So we can use this dynamic programming thing. Now in this case, I have two parameters, which is first previous index and current index, which are changing. In this case, suppose in this case you have to return current index, and in this case you have to return, or you have to take current index plus 1. So these two parameters are changing eventually. So our DP state will have two states. So we have to use a 2D DP. Okay. Now why I have chosen that's 1001 and 1001. So our N is 1000. So basically to avoid the risk situation, I have taken 1001 and 1001 so that it wouldn't be overflowed. Now, whenever I am returning the answer, I have to store that thing inside my DP, which is previous index, DP of previous index, current index. And I can initialize this DP with -1. So, whenever I stored take or non-take inside that DP of previous index, current index, this -1 will be overridden. So I can additionally take that condition that if DP of previous index and current index not equal to -1, that means we have already visited that node or we have already visited that state. Okay, again, whenever we have faced that problem, this is called overlapping subproblem. We don't have to go deep down because previously we have calculated for this state and we have stored inside our DP. We have stored the thing or stored the answer of the state inside our DP. So just return that answer. That means DP of previous index and current index not equal to -1. We have to return DP of previous index and current index. Now there is a catch. Here I have a base case in recursive situation which I already discussed that whenever our current index is equal to the vector dot length, that means uh, it is it is inaccessible. In this case our vector size is 3. So indexes are 0, 1 and 2. So it is not possible to access index 3. That's why whenever our current index is equal to vector dot size, we have to return something. Now what is that something? So if our current index is greater than equal to pair dot size, we have to return 0. Now why 0? 0, 1, 2. Whenever your current index is 3, you are unable to take some index or some character from 3. So if you are unable to take or you don't have any character there, it is not possible to increase the length of the string. So I can return 0, that from there I cannot form a string, or from there I am able to form a string of length 0. So return it. Now here is a point that previous index is equal to -1. But in DP state, we don't have that index which is -1. So we have to omit -1. How we can omit it? Just by adding +1. So just by adding +1 with uh, previous index and current index. So previously our previous index is -1 and our current index is 0. So just add +1 with both. So in 0, in -1, add +1, so it will be 0. And previously our current index is 0, so add +1, which will eventually be 1. Now if you have 0, 1 and 2 and you start from index 1 but you leave one index there. How to access this? No problem. If your current index is 1, just use current index minus 1. Look. So now your previous index is there and your current index is there. Your previous index is on 0 and your current index is on 1. Now you have two choices here because previously you have nothing to check with. That's why you have two choices. So I can take previous index is equal to 0. Previously which is previous index is equal to minus 1. But in DP state we can't access that minus 1 index. That's why you have to add plus 1 so that we can access that 0th index. Okay. So previous index is equal to 0. That means it is the first index. And if it is not the first index, suppose how to access in firstly I am standing on index number 1, but standing on index number 1, how to access index number 0? Just minus 1, just do minus 1. So pairs of current index minus 1 and pairs of previous index minus 1. Okay, because if suppose 0, 2, suppose your previous pointer is there and your current pointer is there. So your current pointer is there, your previous pointer is there. So previously you have taken what? Previous index is on 1. That means what? Previously you have taken 0 because you added 1 with all the indexes. That's why if you are standing on T, you have to look one step backward. So your previous index on 0 and your current index on 1. That's why to check after 0, can I take index 1? Now previous index minus 1. The previous index is 1, but your previous index is mainly 0 and your current index is mainly 1. So to access previous index minus to access previous index on standing 1 to access previous index which is 0, we can use previous index minus 1. Okay, and I am standing on 2 with my current index pointer, but I have to access index 1. How to access? Current index minus 1. That means 2 minus 1. So I can access the previous index, obviously. Same thing, if I take it, our string will increase by 1. If I omit it, our string will not increase. So 0. Now we have to explore for the other index. So we have to explore for other index. That's why current index will be current index plus 1 and same previous index will be current index because currently you have taken the current index. Basically I am not taking the current index, I am taking current index minus 1, but basically the previous index thing is not present. Previous index, if previous index is equal to minus 1, it is not possible to place in it dp. That's why to make sure that we can access this state, I am adding 1 with it. Okay, got that point? Now same thing is there. That means now we have to store that answer before returning in DP of previous index and current index. And I think you all are clear about that sorting, why we have to sort that data. Now time complexity. Previously in the recursive approach, our time complexity is exponential, which is 2 to the power n. Now our time complexity is boiled down to n square. Why time complexity is boiled down to n square? Now basically, whenever I have a problem, I go deep down to it and calculate the result and store the result inside my DP. Whenever again I faced that problem, I don't have to go to deeper level because already I have solved that problem and stored the result inside the DP. So just return the answer of that sub problem. So basically our DP state will visit only for n into n, which is this thing. We have two states and our DP will visit only that two index. So this can go up to n and this can go up to n. So our time complexity will boil down to n square. And space complexity, as we are using 2D DP, so our space complexity is also order of n square. So thanks for this.